All right, everybody. Today we're going to look at lessons 4.2 and 4.3 and find out some very interesting things about angles, how they shape everything, about the shapes. Okay, so let's write at the top of the paper lesson. So this is 4.2, investigate angle similarity. We're gonna write angle. Well, I could use my abbreviation. Anyway, similarity. So let me show you the abbreviation. Well, actually, that is abbreviated A similarity. But I guess you could technically do angle similarity. Now, so this sign is the sign for similar. Okay, so again, this is going to be lessons 4.2 and 4.3. And this is angle similarity. And this one is going to be parallel lines and transversal. Transversal. Transver. Well, let me rewrite that. Who could read that? Transversal. There, is that better? Okay, so when we talk about, let's start with angle similarity. Spark your learning. Asa is comparing the architect's model of a barn with the finished building. He looks at the triangle that forms the front of the roof in the model and in the completed barn. Are the triangles similar? Why or why not? Okay, so you can see this is the blueprint and this is the diagram. So I'm going to take a second and put those in my notes. Ta-da! Okay, so this is a great starting question. And again, this is our blueprint or the plan, you know. Before you're actually going to build a building, you need to make the plan. And I mean, who builds a building and doesn't count the cost first, right? Then you could get halfway done and feel very embarrassed. So you got to make a plan and then you can build your barn. So this is our barn. And the question is, are these two triangles similar? So what is similar? Let's define it. Similar, and I'm going to give a nice definition, not the most precise definition. Okay, just something for us to think about. So, two shapes are similar if they are and I should say two figures are the same shape, but different sizes. This is an informal definition, not precise. You know, I'm not talking about angles and measurements and proportionality, although we'll get there. But I want you to have something in your head to think like, what does similar mean in math? So for example, this triangle is similar to this triangle. You see how they're supposed to be the same shape if I drew them right. But this triangle is not similar to this triangle. And why? Because this one has a right angle. You can see it's a right triangle. This is acute. So this is acute. This is right. And these are supposed to be two similar right triangles. That's what they're supposed to be. So that's what similar means. Okay, so let's talk about if these two triangles are similar to each other. Are they the same shape? They sure look like it. Okay, but what we're going to learn is about something called angle-angle similarity. And so I want to introduce that now because look at that angle-angle similarity, right? So angle-angle similarity. And this implies, and this, I love this double arrow thing. I learned that in college too. I just write it all the time. And it is the symbol for the word implies, or you could say, or you could just say means, but I just love it. Okay. So the angle-angle similarity implies that if two triangles have here's another symbol, congruent angle pairs, then they are similar. Okay, I know I could have just made my little squiggle, but I wanted to write out the word that time. So if two triangles have two congruent angle pairs, then they are similar. Example, let's say we know that we have a 60 degrees over here and a 70 degrees over here. And I have an even bigger triangle, but it has 60 degrees over here and 70 degrees over here. So then we have two congruent angle pairs. Congruent angle pair there. And I'm going to write the symbol there. Congruent angle pair. And we have another, no, this time I'm just going to write the symbol. Congruent angle pair. Okay, so that means that these two triangles are similar. And so this week in class, we gave some shapes names that really helps us to talk about them. So I'm going to write a statement over here to say that triangle ABC is similar to triangle DEF, meaning they're the same shape but different sizes. Okay, this is called the similarity statement. Bam. This is a similarity statement here. It's not even a sentence. It's just two triangle names and the similar sign. That's what a similarity statement is. I've seen a lot of students confused when asked to write a similarity statement on an assessment. They wrote, these triangles are similar. There. Okay, and that's really not the idea. Okay, so back to our investigation or spark your learning problem. We have these two triangles here. Are they similar? Let us see. So first of all, yes, they are. Look, I have 104 and I have 38. So similar, the two triangles, they look like they're the same shape. And because I can see that I have a now I lost my one. I have a 104 and a 104. I have a 38 and a 38. So I'm going to just add right here. Yes, the triangles are similar by angle similarity. Interesting stuff, right? But if you've ever taken a picture and resized it, but then the person looked like they're a different shape, like maybe you made it skinnier or it made it, enlarged it, right? That is because you changed the proportions and they're no longer similar. So that's like when you take and you want to enlarge something, you gotta take the corner, put your mouse on the corner and drag it that way, right? And then you get something that's the same shape. Oh my goodness, I'm writing in the text. Okay, so there's we did the similarity, angle similarity postulate. What did I just called it angle similarity anyway. And now this part in the book, build your understanding. We're not going to do that right now. And also this part we are not going to do because we're not going to talk about angle or equations just yet. Okay, so let's not talk about that. Let us begin talking about, let's do the check your understanding questions. And then in class, you'll be ready to do some on your own questions. So we're going to do 2 of the check your understanding questions. Actually, yeah. And then, okay, so let me pause the video real quick. All right. These questions are just so good because, I taught high school geometries for several years. And so this is a really important question here. So when you look at these 3 triangles, you might think that these 2 are similar because they look so similar. Okay, but actually, if you look here, 40, 42, no, these are not going to be similar because if I take my good old iPhone and take 180, subtract 58, subtract 42, that top is 80. And then if I start from 180, subtract 58 and 40, you get 82. Thank you, calculator app. Okay, so we do not have 2 of the same angles in this triangle, but here, even though it looks different, maybe it's just rotated, right? So I know that 42, 58, 80, so I know that the 80's here. So you can see this triangle is just like pointed in a different direction than this. They're just rotated, but these 2 triangles are similar because they have all the same angles, and we only need to know 2 of the angles, and we know all 3 now. So we're going to say our similarity statement, triangle ABC is similar to triangle, and I'm going to match it up. So I said ABC, I said the 80, 58, 42, 80, 58, so ZYX, ZYX. And then notice the letters are for matching angles. Did you notice that? So angle A is 80 and angle Z is 80. Angle B is 58 and angle Y is 58. Angle C is 42 and angle X is 42. So that's another important part about a similarity statement. The last thing we'll talk about with similarity today is this one. So good. Love this problem. Because you could see something like this in the real world. So we have 2 triangles, XYZ, XYZ, this big triangle that has a line inside of it. And it's similar to LMZ. LMZ. And I'm going to say this triangle is similar to that triangle because angle Well, we already say angle Y is congruent to angle M, right? Angle Y is congruent or the same as angle M. And I didn't define that earlier. Let me define that now. This sign means congruent, which implies same shape and same size. Similar is same shape. Congruent is same shape and same size, which is why it has a similar icon and an equal sign put together. Okay, so anyway, we have these two angles, but we also have angle Z is in both triangles. So we could say angle Z is congruent to angle Z, or we could say it's in both triangles. It's a lot of good stuff there, right? But now we're gonna head on over to one more section. We're gonna climb on over. There's those people there. And you can take a look at the rest of those questions when you get to class, or you can even see this textbook on HMH. But now we are going to talk about one of my favorite subjects for maybe 10 minutes or so. I don't know. I really don't know. And so we have these two sticks, and they're cut by a transversal. Okay, draw a representation. And so I am just going to go ahead and we're going to title this 4.3 parallel lines cut by a transversal. So all over our world, you can see parallel lines. We're going to draw two. In the picture we just saw, these were the sticks, right? And a lot of times, these parallel lines can be crossed or cut by another line. We call the line that crosses over them a transversal. So let's write trans, which means across, versal, which means versal. Okay, and these two lines are parallel. So I put these little icons there that mean parallel. Okay, that's the symbol for parallel, symbol, parallel, symbol. Okay, and now I am going to number my angles. 1, 2, 3, 4, and I have another 4 angles. 5, 6, 7, 8. Okay. And now the question is, in this question, in the book, it asks you to measure all the angles. So we can measure all the angles. I want to give you some special angle pair names, okay? But I want to start out with angles 1 and 5. So in previous courses, like 6th grade, 7th grade, you learn about acute, obtuse, right angles. We talked about right angles in a right triangle. You should be able to see that this angle 1 is an obtuse angle. It's greater than 90 degrees. We know our right angle, right? We have acute angles. Let's just write acute, right. And now we're talking right now about an obtuse angle. Okay? So I'm telling you that this angle is obtuse. This is acute. This is obtuse. No, it's not. That's acute. This is obtuse. This one's obtuse. This is acute, less than 90. This one is obtuse. And this one is acute. Well, guess what? if the lines are actually parallel, and I usually like to label my lines with some lowercase cursive letters, L and M. So let's say that if L is parallel to M, then all the obtuse angles, they're not just obtuse, they're actually the same. And the acute angles are all the same too. And so we give all these 8 angle pairs, there's a whole lot of different angle names. And so I'm going to give you all of them right now. And I'll tell you the ones that are most important to remember, and then some of the other ones are just kind of a little bit. Okay, so the first one, very important, is the corresponding angles. Corresponding angles. And that would be, and I like to say the corresponding. Nobody really likes my funny word there, but that means they're in the same corner. So this one is in the top left, right? And this one's in the top left. So angle 1 and angle 5 are a corresponding angle pair. Can you spot another one? How about the top right? 2 is in the top right. And what's in the top right down here? 6. 6 is in the top right. So 2 and 6 are a corresponding angle pair. They're in the same corner. And we have 4 and 8. And we have 3 and 7. And guess what? If the lines are parallel, we know that these guys are congruent. They're congruent. Okay, they're the same. Now we have an, so that's our first pair, the corresponding angles. Second pair you need to know are the alternate interior angles. Alternate interior angles. And I like to call those the AIAs. Okay, and so in this figure we have a interior, and I'm just writing INT on the interior sides. And then we have a two-piece exterior. The exterior up here and the exterior down here. Well, this diagram is certainly getting very busy. Okay, so the interior is 4, 3, 5, and 6, right? So angles 4, 3, 5, and 6. And so the alternate interior would be angle 4 and angle 6. And also angle 3 and angle 5. And you should notice that those are also the same. Okay, so the alternate interior angles. Now, we also have, let's talk about the same side interior angles. Same side interior. And the same side interior, that would be angles like 4 and 5. Angles 4 and angles 5. And if you look at 4, 4 is acute and 5 is obtuse. 4 and 5 are not congruent, but 4 and 5 are supplementary. And I bet you don't remember what that means because it's been almost a year, but that means they add to 180 degrees. And so that's one pair, and there's one more pair, 3 and 6. So we have supplementary angles, we have congruent angles, and we also have same side exterior, and we have alternate exterior. But I'm just gonna have you guys know about these three for now, and then we can write the others later if we need them. So a lot of information. Did I? Okay, so are we going to page 3 of notes? That means we must be very near done. Okay, so so look at that. I didn't even get to this page, but we have already defined transversal, alternate interior. We didn't do alternate exterior. We did same side interior. We didn't do same side exterior, but it's there. We can do it later. And corresponding, I don't know why they did that last. That should be first, but it's okay. HMH, do what you want. Now, the last thing that we're going to do here is we're going to use, and again, we're going to come back to these diagrams later when we get to angles, or I mean equations, but we're not going to solve any equations right now because we haven't done that yet. But we can take our knowledge and find, we're going to step it up. So parallel lines and transversal. Step it out. Don't worry, guys. I know I'm almost done. Okay, so I'm going to draw the parallel lines, cut by transversal this way. We can call this 80 degrees. And now, knowing my corresponding angle down here that's their corresponding. And if these lines are parallel, then that must be 80. And then I know if that's 80, then I know that this 8 is across from it is a vertical angle. So they're 80. That's from 7th grade, right? And here we have another 80. And then we know that our same side supplementary. So this has got to be 100 because they have to add to 180. This is 100. And then that must mean that this is 100 and this is 100. So the cool thing about these different angle pair relationships is if you just know one angle, you can end up getting all 8 angles because there's only 2 different numbers. And they're either going to be the same or they're going to add to 180. Notice that 80 plus 100 equals 1. All right. Let's just turn one page and see if there's any additional things. So we can do this part in class, a little triangular rowing problem and a little bit of real world bridge example stuff, but you can see down here in the check your understanding, another problem where they give you one angle, you find all 8, and another one, they just put a little decimal. You could do it. We got some same side interior angles there. Okay, it's good, guys. Did a great job. You made it through. I will see you in class.